Hi guys, let's talk about the power functions. Welcome to my channel again. And for our power functions, it's pretty straightforward because actually if it looks like this way, fx equals x to the power of r, it's a power function. But before we continue to do more like this weird and like really big or small powers, let's look at increasing and decreasing function at the first. So if we say the function is strictly decreasing, it means like keep increasing. So it means if my x2 is greater than x1, it implies or it means that fx2 is always greater than x1. Okay, and if we talking about strictly decreasing, so it means if my x2 is greater than x1, so my fx2 always less than my fx1. So it's gonna be looks like this. Okay, and it's pretty straightforward. Let's keep going. So for the next part, it's power functions with positive integer index. So it means for this part, we just distinguish in two things. One is called even, one is called odd. Okay, if it's even like y x squared or x to the power 4, it's always look like this. Okay, basically means non-negative. Okay, but once the power function is become odd functions like x to the cube or x to the power 5 or continue, so it's gonna look like the general shape gonna look like this. Okay, and for this part and this part, we will continue working on in chapter 4 with a polynomial. And for now, we just need to know the general shapes of its graph. And again, this is my point. I emphasized before, odd positive integers, so such as 5 and 3. But just make sure one thing, okay? If your teacher or the assignment or your SAC ask you to draw the graph in the same x-axis, so from 0 to 1, okay? My x cube always greater than x to the power 5. And after this point 1, 1, after x equal 1, my x5 is going to be greater than x to the power of 3. Okay? Because let's imagine we have half over here. So my half cube is only 1 on 8, but my half on power 5 is 1 on 32. So it's much less. Okay? And the next part is like even positive integers. Again, for -1 to 0 and 0 to 1. The more bigger power, the less value is. Okay, just make sure you notice this one. And sometimes we're gonna dealing with this one, okay, like the negative integer index. So for this part, for some certain notation, I just emphasize x to the power of -n equals 1 over xn. Okay, I just want everyone to know that. And this one is pretty important in chapter 5 once you guys learn the exponential functions. So, and hopefully you still remember 1 over x. This one we call rectangular hyperbola. So it's going to look like this. Okay. And you may say, sir, I've kind of like forgot, or forget, or like even cannot remember how to draw the graph. But don't worry, we always can substitute value from x, y, then substitute the value, then you get the idea how the shape gonna look like. Okay, and let's keep going. So for this one, they ask you to find the rule for 1 over x to the power 5, but again, this one is similar as our 1 over x. Okay, the only difference is passing the point. It's a bit different, and it's going to be increase or decrease more, faster. Okay, and again, if they ask us maximum domain, so which means our denominator can never be 0. Okay, this question is pretty straightforward, and you can pause the video and read through or try yourself. Okay, And same here, to the x to the power of -3, it means 1 over x cubed. Okay, so which means here, okay, 1 over x cubed. Yeah. And now they ask you to sketch the graph of these two on the one set of x-axis, which means the same x-axis, right? So here, be careful. They might have the intersection, so you have to draw it. And you also need to clearly show the relationship. I mean, the relationship means the position, okay? Which one is higher, which one is lower, okay? And use the arrows to indicate the different graphs, okay? Because in the final exam, you might only have one blue pen, okay? You cannot use like red or blue, to demonstrate which one is which. So you have to use the arrow to indicate which graph is which one, okay? Just make sure clear label, okay? And let's keep going. For this part, it's even negative integer, so the basic one we learned in the math method unit 1 and 2 is 1 of x squared, so it's truncus, okay? And once it's become even, again, we don't have any negative things, so we only have the positive, or we should say above the x-axis, okay? And let's keep moving. So this is the one I like to emphasize here. Okay, oh sorry, this is a to the power of 1 over n equal n to the square root of n. Okay, so which means square root 4 means 4 to the power of half. Okay, so make sure you know this one. And again, once we know this, we got a lot of new graphs. So the first one is square root of x, which is this one, pretty basic one, and we learned 1 year before. And this one is a bit tricky. This is x to the power of 1/3, okay? And as we know that under here, the power of 3 or power of 1/3, it can be negative or positive. So our graph is extend. By extend, I mean for the even power, we only have the greater than or equal to 0. But for the old one, okay, we got the positive, we got the negative as well. You might say, okay, so it's a bit, hard to remember or difficult to understand, but just remember this one is the inverse function of y equal to x cubed, okay? Make sure you know this. So you know the graph is symmetry about y equals x. So if you know this one, you must know this one. So don't worry, you can get it through other strategy as well, okay? And the next part for this part, again, they just ask you to draw the graph like the power functions. So it's straightforward, and sometimes if the power function is really awkward, it becomes a polynomial one. Otherwise, we have the strategy, and they give us special numbers, so we can factorizing, or you can use cas to help you to get the function, okay? Okay, now this part is an inverse of the power function, so hopefully you guys still remember what is odd function or what is even function, because sometimes we need to use this one. But for now, in here, you only need to remember this one. Okay, if n is an odd positive integer, then fx equals x to the power of n is strictly increasing. Okay, in this book, they gave us different case and they prove it for us. So if you are interested and you want to know why this is the case, you can go through each case and understand, okay? And my suggestion is you can plug in some special numbers, like maybe let's say a equals 2, b equals 1 to give you the idea, okay? Or in case 2, you can a equals 2, b equals -1, and so on, okay? And for this one, again, the proof things is not that important. Just this one gives you some certain ideas. Okay, if f is an odd one-to-one functions, then f inverse is also an odd functions. Okay, that's it for my power functions. So to be honest with all of you, the power function is not that important. based on, I mean, the importance is really depend on the question they put in the final exam. So if you don't have that enough time, this part, you just need to look at the section summary to understand what is strictly increasing and what is strictly decreasing. And then just know the basic graphs, okay? Then it will be fine. Because later on, for power functions, they normally combine with polynomials, and then they're gonna put on your final year exam. Like normally for the first, I mean year exam 2, first question, okay, it's normally about polynomial, and it can be combined, and it will be combined with derivative and integration for this part, which is covered and will be covered in term 2, okay? So I guess see you guys for next videos, and hopefully you like what I explained, and please make sure you like my videos and also subscribe if you like. Okay, thank you so much guys. See you for next one. Bye bye.